Hi, this video is for anyone of my colleagues who saw the seminar I gave on the use of Google Earth Engine and some of the things that we can do with it, and or anyone interested in using the TreeMap product and joining it to summaries of FIA attributes at the plot level. So to begin, the first thing I did for this is to load the TreeMap product from the Google Earth Engine catalog. And the way I did that is I typed in USFS here. You see that TreeMap is one of the first rasters that pops up. So if you click on that, you get to a description of the data set. And what I did is I loaded the example data. When you do that in a blank code editor, the example code which is the basis that I'm going to use pops up. You need one more thing, and that is the lookup table that goes from the TreeMap ID, which is what the raster actually consists of. The pixel values are a TreeMap ID value, to a plot.cn value. And the plot.cn is the plot level record identifier in our FIA database. So the place to find that, if you go into this, there is a research data archive. So if we right click here and we say open a new tab, we can go to that, and you will see that there is a location in here where you can navigate to the actual data file. And at the bottom here, you'll see two files, the metadata and the actual data file, which is gigantic, 5 gig. So you have to download that, unfortunately. You don't use the raster, the giant raster in there. What you use is a CSV file that comes along with it, which is basically just a lookup table between the TreeMap ID and the plot.cn. But I'll show a little bit more of that in a second. So I downloaded the zip, extracted that CSV from the zip, and then we end up with a file that we can look at it in R. And that file is called TreeMap 2016 tree table. That's the file that came out of the zip. So I read this into R. I filled in some NAs that are in that file with a 0, and then I calculated a new column in that file called basal area. And what that file looks like is this. It has the TreeMap ID, and again, this is the pixel value that I'm going to be joining the CN or joining the FIA data to based on that, based on this lookup, and one row for every tree in the database that was used to make TreeMap. So what I can do is I can summarize this file to the TMID or plot level, or your plot.cn level. So for example, I can get the total basal area of loblolly pine on TreeMap ID, value 746 across all the 746s, because you can see loblolly pine. There are several trees. I think there's 21 trees that occur on that plot. So that's what I do in the rest of this code through a series of steps, and I break it up into pieces so I can look at each intermediate result. But the final result looks like this, and what we have is a TreeMap ID. Again, this is going to be what's used in the lookup in Google Earth Engine, and the columns are the individual species that occur in the whole country, and the percent basal area of that species that the species represents. So for example, on TreeMap ID number 1, 1% of it is persimmon, 0.4% of it is flowering dogwood, 1.8% of it is laurel oak, and the rest is loblolly pine. And everything else is 0. So that should add up to 100%. It might not, but there might be one off to the right, but you get the idea. So it's this file that I import into Google Earth Engine. And I do this, let's see here, through the interface that I showed in this seminar. But basically you go to an Assets tab, you say New, CSV file, and when you do that, you get into a dialog where you can navigate to the CSV file that I exported from R that I just showed you, that result3 file, and upload it to an asset. So I did that, and that asset pops up in the folder or the project that you want it to be in. And what that looks like, if we just click on it here, we can sort of examine it a little bit. We can see it's the same file, the same CSV file that I just um, got out of Google, or excuse me, got out of R. It's reorganized, but it's the same file. So the next step then, once I've got that in there, is I made some edits to the code. Oh yeah, I import it. So once it's there, you can click on this arrow and it imports it. And I named that import, which was the default name was table. I named it a specTab just so that I kind of know what it is. So then I added some code I found on the internet because I knew that I wanted a gray map because the satellite and the map view are going to interfere in terms of the colors with the file I'm about to produce and draw. So I wanted something that would appear on a gray background. So I added this bit of code, which again, I didn't write this, I just found this online. And this is the code I found. I just copied and pasted it, and it ran immediately when I ran it. So when you load the default data set, this example data set, like I showed you earlier, initially, all of the pre-calculated tree map layers load here as options, right? The one I'm interested in, and they've pre-calculated these, so these are actually all sitting, I don't know how many there are, let's say there's 20 of them sitting on Google Earth Engine in their cloud database. The one that I'm interested in for this exercise is the value raster. So think of these as different bands or different individual single layer rasters, right, that I'm going to be working with. Value is that tree map ID raster, where if I clicked on a pixel, it would indicate that it is one of those tree map IDs that we just saw in the lookup table. So I make a new variable, and which is basically just a list of the unique tree map IDs. And I use this code, which I just happen to know, but you can use the same code or you can figure out what it means. I'm not going to go into details about that. But in effect, I'm turning it into something called a feature collection, which is a file that Google Earth Engine can work with. I'm selecting out just the tree map ID column, and then I'm doing this aggregate array function, which just extracts a column of the unique values. So that's the from. So I'm going to be remapping the map from the tree map ID value, which is the raster values, to, in this toList variable, a map that I want to make. And in this example, one of my 350 or so species is red maple. So I do red maple, and I have to make that change here, and I make it here. I also know that I'm going to be making a map of it. So down below where I add it to the map, I have to change that here too. I could make the code such that it just references a text string and just change it in one place, but for this example, I'm not going to bother with that. So I've made those simple changes, and I'll show you one more change I've made after I hit the run button here, and I will show you what happens. So I hit the run button, and it chugs along for a few seconds. I'm going to pop this up here. And a few things happen. Some things pop out in the console. What I've done is here I've printed, and you can use the print function to print something. So this verifies that there's the same number of unique tree map IDs in the map as there are in my lookup table, and that's important. You have to make sure that that happens. So if you were doing this in a different way, in other words, you were making your own tree map ID FIA attribute lookup table using Oracle or R or something like that, you just have to make sure that the same number of rows in the TM, that tree map CSV file occur in your output, and that's what you bring over, and that's what I've just verified. Right. So I'm also printing the minimum and the maximum value of my value of red maple. And I'm just doing that just to show that the values range between 0 and 1. This doesn't do anything, it just displays it, and it verifies that everything is as I expected it would be. So then I've got some code in here where I choose a color palette, and I won't go into that, but basically this is a function that somebody made with a whole bunch of different color palettes, and you can choose one. For instance, a color brewer palette that goes from red to yellow to green with 11 classes. I don't use this one. I use just a color brewer palette with 9 levels of green, going from light to dark, dark being more higher proportion basal area. I did some other stuff that I'll talk about in a moment. So here's the red maple map, right? So this looks like a okay map, but I might not like the way it's displayed, or I might want to change to a different species, so that I can make some decisions here. So something I did was I made a second visualization based on a second map that I produced. The second map that I produced with this little bit of code takes this species map, which is the recoded TreeMap ID map, which now has values of proportion red maple ranging from 0 to 1. And I applied what if you're familiar with ArcGIS, it's a focal sum or a zonal sum, where I create a 7-pixel kernel centered on each input pixel, and then I just sum up the proportion basal area of red maple of all the pixels within that kernel, of all the 30-meter pixels within that kernel, and return that sum to that pixel. So in effect, this is an index of the proportion basal area in the area surrounding each pixel, i.e. within a 250-ish meter circular window. So I produced this map. I have a second set of visualization parameters, so that because the minimum and maximum no longer range between 0 and 1. And I will add that layer here using this code. So this adds the value layer, this adds the normal map, and this adds the kernelized, the zonal, or the focal statistics, focal sum layer. And I will just hit the run button here, and when I do that, you saw within a few seconds everything loads, and I have the red maple map, and I have the zonal statistics map, and I have the value map, which is a little kind of uninteresting. It's just basically a grayscale because the TreeMap IDs range, it's just a continuous value that doesn't have any physical meaning. So I might say, well, that's great, but what about another species? Well, if I want to make a loblolly pine map of the same thing, say loblolly pine, let's copy this here. I will paste it, loblolly pine, and then I want it to show up nicely in my legend as well. Oops. And I will make the map of loblolly pine here, Control V. So I'm selecting just the loblolly pine. So I had to make this in my code. I had to make the change at 4 places, but again, I could have just made it in 1 if I made it as a text string, etc. But again, I'm not going to go to the trouble of doing that for this example. So anyway, I can hit run, and it's thinking, and this is real time. I'm not like pausing the video or anything. It is going to make a map of loblolly pine. The same thing, the proportion per pixel, and then the sum of all the proportions per pixel in the area around it. And we can see that it loaded already. So we've got the raw map, we've got the smoothed map, which maybe looks a little nicer. It doesn't look quite as blocky as the initial map. And we still have the value map. So what's the point? The point is, using this technique, you can take that lookup table we had in R, do whatever you want to calculate new variables based on the species that are already there, or you can do your query in SQL, generate a plot CN level summary, you could join the plot level CN data to a TMID value so that you've got the TMID for each plot level summary. Save that as a CSV file. Export that over to Google Earth Engine. Like I showed you, you've got a new asset over here. You import the asset, and so you've got access to it in the data file. You then use a very simple make your lookup table, your from list, which is from your table, your to list, which is the attribute you're interested in. In my case, this loblolly pine that I created, and you can load the images, and you can do stuff to the image, such as a focal statistics, and again, it happens instantaneously. These things can be exported as national scale rasters or used in other analyses further down the line. That's all I wanted to show.